All right, so this is the, what is this? The 2009 AP question number 4, and it's an array list question. So this is, I don't know, a little bit harder than the average question, I would say, but it's actually probably my favorite question. So it says, a game uses square tiles that have numbers on their sides. Each tile is labeled with a number on each of its 4 sides. It may be rotated clockwise, as illustrated below. So you got this is the initial tile, 4, 3, 7, 4, and it can be rotated clockwise, where this 4 right here would be at the top here. This 4 would be rotated to the right, this 3 rotated, and this 7 rotated. So you can rotate this thing 3 times before you get back to its original spot. So a total of 4, so that'd be 1, 2, 3, and then 4 rotations. Okay, so the tiles are represented by the number tile class, where the number tile class knows how to rotate, which is this is what I showed you up here. It then can get the position at the left, wherever you're at, wherever the tile's at, you can get the left position, and you can get the right position, and that will return, the integer value of whatever you're on, okay? So tiles are placed on a game board so that the adjoining sides of adjacent tiles have the same number. The following figure illustrates an arrangement of tiles and shows a new tile that is to be placed on the game board. Okay, so think about this. Array lists can hold objects, so each number tile class, each of these is a different tile, okay? So each of these knows how to rotate and get left and get right. So when we want to put on you could put on a new game piece, a new tile piece. And so this is position 0, position 1, position 2, position 3, and position 4, okay? So it says, in its original orientation, and let me go up here, the new tile can be inserted between the tiles at position 2 and 3. So between here, what we're going to do is we're going to check to see if the left-hand side number matches up with the right-hand side number of where you're at, and does the right-hand number match up with the left-hand side of, so it would fit in between here. So that would mean this new tile piece would fit in position 3, and position 3 would move over 1 spot, and position 4 would move over 1 spot. So you are inserting that in there. Which is what I basically just said here. If the new tile is rotated once, it can be inserted before the tile at position 4. So let's look at that. So if this is rotated, where 4 were to go down to here and everything would rotate, then you could actually put it in position 0, because the 4 would be right here on the right-hand side, and that 4 right there is on the left-hand side. So you can insert that in there. So that would work if you rotated it first. Okay. Assume that the new tile position in its original orientation is inserted between the tiles of position 2 and 3. As a result of the insertion, the tiles of position 3 and 4 are moved 1 location to the right, and the new tile is inserted in position 3 as shown below. Okay. So then we got a tile game where you've got an array list of number tiles, and your array list is called board. So it holds number tile. Your board holds number tile objects. So you've got your tile game constructor that's constructing a new board which is an array list again of number tiles. So let's keep going down. Part A. So it says write the tile game method get index for fit that determines where a given tile in its current orientation fits on a board. A tile can be inserted at either end of a board, a game board, or between two existing tiles. If the sides of the new tile match the adjacent sides of the tile currently on the game board. If there are no tiles on the game board, the position for the insert is 0. So if there's no tiles on our board, then we just insert it at position 0. So that's easy. The method returns the position that the new tile will occupy on the game board after it is to be inserted. If there are multiple possible positions for the tile, the method will return any one of them. If the game tile does not fit anywhere on the game board, it returns -1. So you'll insert it wherever it goes first and return that position. So if it goes in position 0 first, you'll return 0. If it goes in position 1 first, that's what you'll return all the way down. And if it doesn't fit anywhere, you'll return -1. Okay, so this tile 1 right here, 2 and 2, that would fit in position 3 right here. Because both of those match up. The 2 on the left-hand side matches up with the right-hand side 2 in tile position 2, and the right-hand side tile, or position 2 of tile 1, matches up with the left-hand side 2 on tile position 3. But tile 2 doesn't fit anywhere, so it would return a -1. So I think that's what it says here. For example, the following diagram shows a game board and 2 potential tiles to be placed. The call get index for fit tile 1 can return either A or 3 or 4. Okay. So it could be put in there, but just the way how the code works, it's going to be put in between tile position 2 and 3, which means it's going to go in position 3, even though it could potentially go in position 4. So the tile 2, yeah, it returns -1. Okay, cool. So what I did is I just, this is a PDF. I can't write on this, so I'm going to type it out in my, right here. Okay, so one of the things, so whenever you're working with, array lists, you've got a list of information, but an array list is going to have some sort of, in this case, it's going to be an array list of number tile objects, and those number tile objects know how to rotate, get left, and get right. But whenever you're at your index position, you always have to get, what index it is. You can't just say, well, I'll show you here in a second. So let's see what this one wants right here. So you always have something like this precondition before the method that you're going to write. So we're going to write this first one for part A. It says determine where to insert the tile in its current orientation. Into game board. All right, so again, it's got to fit in position 0. It's got to fit in the end position, the last position of the game board, or somewhere in between. So that gives you a nice little if statement to figure that kind of stuff out. All right. So parameters: the tile to be placed on the game board, right there. That's the tile that's going to be placed. Return the position of the tile where tile is to be inserted. 0 if the board is empty. -1 if the tile does not fit in front. Okay, so first things first, you have to return an integer. So return -1. Okay, so we're going to go over the point structure, but my guess is just doing this line of code would give you a point, which is basically you're returning -1 if all of our preconditions that we're going to write don't work. Okay, meaning that it's not going to find the position, so it's going to return -1. That probably gives you a point right there, and every one of you can write this. So part of this with programming, the written programs and getting your max points are using some of these strategies that are really easy. Remember, I've always said in this class, you can do very, very well on here if you don't miss the easy stuff. You can miss the hard stuff, I always say, but you can't miss the easy stuff. So let's think about the easy stuff here. Okay, so we know that if a tile works in position 0, meaning we throw this in, let's say there was a 4 right here. Couldn't that match right there in position 0? So let's program for position 0 first, okay? So if, let's think through this real quick. If, so there's 2 ways it could be position 0. There's no tiles on there, so if this dot, maybe I need, yeah, let's do it. If this dot board dot size, so the size of the board is equal to 0, or so if the board is 0, then we're gonna put we're gonna return 0. Okay. So look at that. That actually, let me think here. You know, again, we're working through and thinking about all possible ones. But if it's at 0, return 0. Okay. But also, you know, you got to make sure that, you know, if this tile piece right here was rotated and 4 was right there, then that would also match up. So how would you do that? You would check to see this tile piece, and we could get what's at the right position if it equals, you know, what's at this tile piece at the left position. So let's look at this. So we could say, and I'm going to put it, like, again, I'm going to go back because I want to hit all of my, we could say, or what? The tile that was passed in dot get right, like I just said, the right position, if that was equal to this dot board dot get at position 0 dot get left. Now again, so let me see here. I don't want to mess up with, so I need one more right there. Okay, so if there's no tile pieces right here, you put in, you return 0. If the right tile piece is equal to the board, which is an array list of what, number tiles? Yep, number tiles. It's an array list of number tiles. This is the big thing. You can't just say this.board.get left. You don't know which board piece you're talking about. That's why you get what's in index position 0, which is right here. Get what's at index position 0, and then you get the left position of that, okay? So that's pretty easy. I mean, that shouldn't be a hard one, okay? Now, what do we do if we want to put it at the end? Don't we have to go, like, let's say this was, again, rotated one spot, and the only place that tile 1 would fit would be on the end. So it wouldn't fit in any of these. It would just fit on the end, all right? So we got to do something exactly like this. So we would say what? We would say So this would be, you know, your yeah, I'm gonna erase this, but this would be like your position 0. This would be your just the end position. So last position. Okay, so you could say if you'd return this dot board dot size. So size is for an array list, just remember that as well. So if tile dot get left, so if your tile piece, remember, let's say this was rotated 1, so if your tile piece at the left position was 9, if it's equal to this dot game board dot get the right position, if they're equal, okay? So if this dot get left is equal to this dot board dot get now let's think about this. Get, and then we don't want to do the size of it, because remember the size is, so the size would be 1, 2, 3, 4, 5. There's 5 pieces here, so the last index would be 5, so you can insert it into position 5, but you want to do size minus 1, which would give us 4, and that would give us, we would get the tile piece at position 4, and then we can compare the right side of position of the tile at position 4 to the left side of the tile. So, and that's where we did if the left, okay, if the left position of the tile is equal to the right, so we need to do this dot board dot size minus 1, and then once we have that, we can say get right, and that would return. So just right here, to me, these 3 so far are pretty easy, and if you were to just program that, I imagine you would get a pretty big score on part A. But now we got to find everything in between, okay? So let's do this. So so tiles in between. I don't know what I'd call that, but let's just say tiles in between. So this is where you got to do your for loop. So we're going to start at index position 1, int I equals 1, okay? Because again, we're not starting at index position 0. These are all in between, so we have to start at index position 1. And then we would want to do our size and go through each one, okay? So we could say what? Int I equals 1, I is less than this dot board dot size, I plus plus, you know, and we're going to return I if we find it, but we definitely have to have like an if statement in here somewhere. So if, so we would say if tile dot get left is equal to this dot board. So let's say we're looking at this piece right here. So the tile dot left is equal to this board dot right, but we want to do the index that's less than the previous one. So whatever, if we're in position 1 right here in our loop, we would compare it to the board piece position at 0. So we have to do this board dot get I minus 1. So that would be position 0 dot get right. Okay. And so this one would check against this one right here, the right position of what's in element 0. And then we have to check we have to do tile.get right and compare it to the left position right here of tile 1. Okay. So, and this dot get right is equal to this dot board dot get what's at position I. Remember, at position 1. So we got to compare what's at this dot right and compare it to what's at position index position 1 of this piece, and this will be get left dot get left. Okay. And so this would be 0, this would be the last position, and this would be somewhere in between. And if none of these get hit, then we return index position at 0 or at -1. It doesn't work, okay? So I think that's right. We're going to go through the answers here in a minute, but I think that should hit all of them. Okay, so part B. It says, write the tile game method insert tile that attempts to insert the given tile on the game board. The method returns true if the tile is inserted successfully, and false only if the tile cannot be placed on the game board in any orientation. So, let's see here. Places the tile on the game board if it fits. Check all possible orientations if necessary. So you pass your tile. So let's think about this. We're going to pass our tile in. Okay. And then we're going to end up calling this method. If it fits, fit it in. If it doesn't fit, meaning -1 is returned from here, then we have to rotate it one spot. Okay, so for instance, let's see, does this one rotate and work anywhere? So this one, tile 2, doesn't fit anywhere in here. If we rotate it 1, it would be 9 right here and a 4 right here. That would fit at the end there, so tile 2 would fit, and then the program would be done. Yeah, all right, cool. So this one's kind of fun too. I like this one. All right, so first thing we got to do is we got to check to see if it needs to be rotated, all right? So this is where we've got an int index is going to be equal to get index for fit. We pass in the tile, and that's going to give us an index position where it can be inserted. Okay, so let me think about this. So if our index is not equal to -1, then what do we do? If it's not in, then we need to insert it or add it. Remember, .add is something that ArrayList can do. So this .board.add, and you would have to add the index position and the tile piece, and you would return true, else you would return false, right? So if it's not -1, meaning it can fit in there, but this would be only for the first time through, okay? Again, we haven't rotated, so this would be like, can this tile piece go in anywhere? If it can, it's going to return the index position where it goes, because that's what A does. It gets the index. And with the code that I have written so far, if it's not -1, then we add the piece, because now we have the index position to add to where to add it, the index where I'm going to add it, and then you add the piece, and so then you return true, because this is a Boolean accessor method that wants to return true if you can add the piece, or false otherwise. Okay, so now what do we want to do? Now we got to test if it returns -1. So let's say we'll say what, int tile rotations equals 1, because remember, we have to rotate the tile if it returns a -1 here, because we got to check every single position. Okay, so while index is equal to -1 and our tile rotations is less than 4, because you can only rotate it, around 4 times, then what do? If it returns a -1, then we have to say tile.rotate. We got to rotate it. Our new index, we got to do this basically line of code again. Okay, so we rotate it, and then we check to see if the new position works. Okay, because now we've rotated it 1, and now we're going to pass the new rotated tile in here and check to see if the index is not equal to -1. And then our tile rotations plus, meaning we have to add up, because remember, your tile, you can rotate it as many times as you want, but like eventually this 4 is going to rotate to here, and then here, and then here, and then back to its original spot. So there's no point in to rotate it more than the 4 times. Okay, so let me think here. I think that is it. So so now our answers, and maybe it's best not even to look at the answers. I've done this many times, so I know the answer is correct, but it's probably best to compare and look at how this thing is graded. Okay, so let's open this up a little bit, and I am going to shrink this down. Okay, so for part A, what does it say for part A? All right, checks to see if there's an empty board. Checks for a 0 size board. That's what this does. Remember what I said, you're going to get good points. Return 0 if it's empty. So if you just did that part and that part, return 0, you're going to get a point. Okay. see here. Access any tile from the board. Accesses all tiles. So any tile would be basically this right here. You're checking if there was one piece on there, you would check your right tile piece and compare it to the left tile piece on the board, and if it's there, you'd return 0. So again, access all the tile elements. That's where, you know, to get this, again, if you did this piece and you did this piece and you did that, you would get already a 1.5. Now you would miss this because you didn't access all the board pieces. That's where you have to do that for loop to run through every board piece. But again, like I said, you can do the easy stuff and do really well on the test here. You really have to know your business in order to get the full points, but don't leave anything blank. Write down what you know. Figure out the easy stuff. If you can't figure out your algorithm like this right here, that's fine. You can still earn a lot of points. So uses tile values, accesses a left or right value of any tile. So again, this one accesses a left or right tile. This one accesses a left or right tile. So you get a 0.5 point there. Compares the left-right value of perimeter with right-left value of any tile piece. So that would be another point right there. Again, if you didn't get the algorithm, you're still getting, you're up to 2.5 points on this thing, and you've only missed a 0.5 point. Determine the tile fit. Only right value of perimeter compared with left value of initial tile of board. Only left value of determines only left value of perimeter compared with right of final tile of board. Only right value of perimeter compared with the left. Interior tiles. So I think this is the left tile piece, the first one, the position 0, and this would be the last position that you would throw it in the size of the board, and then compares appropriate values of the interior. So again, you would miss a point here, so you'd be out a 1.5 now, but you would still get a full point. Result returns located index if the tile fits. Returns -1 if it doesn't fit. So see that right there, just return -1. That would give you, you know, a 0.5 point. Returns a located index. You would miss a point right there if you didn't do this interior piece, I would think. So, but you would have done okay. You would have gotten one. Yeah, what did we come down to? It would be like half. 1.5. You'd have missed 2 points on this whole thing. So 1, 2, 3, 4, 5. So there's 6 points. You would have gotten 4 out of 6. 4 out of 6 isn't shabby. It's more than half the points on written. So again, not too bad. So the last one, let's see how it grades it. So invokes get index for fit. So the biggest thing here is that you have to call this get index for fit. We just built the previous. What I'm seeing more of is that they want you to be able to call the method that you already built and implement it. So you need to be able to call it and implement it and get the index position. Invokes rotate on the parameter. That's that. Performs all necessary rotations. Well, you need to have this while loop working property to do all the rotations. So if you don't have a while loop, you won't get that point. Invokes that for each necessary orientation. So again, you need to have this line of code inside your while loop. Adds tile correctly and only if the get index fit returns value of other than -1. So this line of code to me is easy. That gets you a 0.5 point and returns true. So yeah, so you get right there. So in my mind, you can do this and you can do these two right here easily, and that would give you 1, 2, 3. So this whole thing is worth what? 2, 3 points. So 1 point. So I don't know, 2 out of 3 should be really easy mop-up points. So 2 out of 3 points. So if you got 2 on this one and 4 on the one before, that's 6. 6 out of 9. You know, that's, in all honesty, good points right there. If you're getting 6 out of 9 on all your written, you're, depending on your multiple choice, you're going to get a 4 or 5 on your AP test. Now, to me, the while loop in this is a little bit harder. To me, it's easiest to just come up with one case where this is going to work. Same with A. It's easier for me to think through, well, I can add it to position 0 or I can add it to the very end. This part is harder to think through with the loop and algorithm to do it for every single piece. And this while calling it 4 different times, that's harder to think through. But in my mind, if you did that, you called that, and then you did the if-else statement, you would have done it one time, and you know your while loop would be screwed up. But based off of their canonical and how they're grading, I think they have to give you the bulk of your points. So again, hopefully you get 100% on these, but you know, I'm also realistic and know that part of this is just test strategies and how to think through this. So anyway, this video's done.